Hello, welcome and a very good evening indeed. Today I have something new to solder, and actually I'm working on a different video in theory right now, but I had some problems with that which led me to this video. We will do a little bit of soldering practice actually, because it turned out while I did quite a bunch of soldering in the last 2.5 years, I have not enough practice in certain areas. The usual kind of soldering is what we saw, for example, with the Adlib or the Snarkbarker card. This is the Snarkbarker card, and you probably know it. If you don't, I will link to that in the video description and up there. And the Snarkbarker card is a so-called through-hole soldering card because there are holes through the PCB or printed circuit board. On the other hand, we have so-called surface mount PCBs and components, which are something like this tiny sound card here. And as you can see, all of the components, except for the large capacitors, they are so-called surface mount. That is, there are pads on the PCB to which the components are soldered, but they don't stick through to the other side. That's why they are called surface mount. So the project that I'm going to show you today is also for surface mount components. So I bought this here. As you can see, there are tons of tiny little components here, resistors, capacitors, and LEDs, and even one chip. And there's a PCB in here. And this is a learning kit for learning to solder SMD components. And it's pretty cheap. It's less than €2, I think, shipped even from China. So I bought 3 of those to, well, practice, because only with practice you're getting better. So let's go over to the desk and start soldering. Okay, what do you need for this kit to solder, actually? Well, you need a soldering iron. I'm using my ksgr T12 soldering station, which is a cheap Chinese open source based microcontroller based soldering station, which is pretty nice. But you can use any old soldering iron. There are better ones and worse ones. I will link to the review of the T12 soldering station. Again, it's best to also have a smoke absorber. The FA400 is what I use, so that you don't inhale the fumes of the flux in the solder or in your flux paste. It's all about your health. I also link to that. You also need the flux paste. I'm using Emil Otto EOFP002 in a syringe. You can use a flux pen or whatever you like. You already have flux in your solder. If you buy this one here has 5 flux cores. And here I have 2 different Stanol brand solders. One is, I'm not sure, 1 point something millimeter. This is this one. This is a bit thicker, and this is better for through-hole purposes. So I'm putting this aside. Both are lead-based. Due to environmental regulations, lead-based solder is not allowed to be sold anymore, except for repair purposes, and then only for companies. As a private person, you can't buy this anymore. So these are my old stock, basically. If you buy lead-free solder, it will have some copper and some silver usually in there. And it's a bit different to solder with that, so you have to practice a bit with the lead-free solder. So we'll put all this aside, and we will have a look at what's inside of the kit. And you can already see, this way around, there are 2 ICs on there. The back side also has some stuff, but this is only for reference purposes. It shows, the first interesting thing is different sizes of SMD components. Then you have different chip packages. This is an SO style package. Then you have a finer pitch on all 4 sides, the QFP package, 44 for 44 pins. And as you can already see, we have different size components in here, 1206, 0805, 0603, and a couple of 0402. And we'll practice all of these. And let's see what the instructions say. They are in Chinese, naturally. And they even explain how this works. So basically you tin one pad, this is the solder, this is the iron. After tinning you will have one pad with a blob of solder on that. Then you take some tweezers, you put down the component with the tweezers and heat the solder blob with your iron. And then it will fall in place and stick. And it helps to add a little bit of flux. You will notice if there's too few flux, then you will make some spiky protrusions and it will be harder. And once you have attached one side, you can just take your solder and your solder iron and tack down the other part, and then you have a finished component. Here's the PCB layout and the connections. This is probably the bill of materials, which might be interesting because there are some values on here. So resistors are these little black thingies with 3 numbers on them. And the first 2 numbers you take literally, and the last one tells you how many zeros to add. 5, 1, 0. That is 51 plus 0, 0, so times 0 extra zeros. And this will be 51 ohms. These are 51 ohms. These are transistors, if you ever wondered what they look like. They have 3 legs, just like the big brothers of them. And you can see that everything comes in these little packages with the dots on one side. And these can be fed into pick-and-place machines. The pick-and-place machine is basically a robot. It will feed off these reels and take out the components and place them automatically on the board with solder paste and then solder them in place by using hot air or something, or a reflow oven or something. So what do we have here? These little things, these brown things with the silver ends, they are capacitors. They are just normal ceramic capacitors. So I ran the the bill of materials through the translator, and this actually means random. So they basically took whatever values they got for this. And yeah, this is the numbering, how you should proceed from easiest to hardest, I guess. And yeah, we will begin with the number 1, which is the 1206, which are these things here. They're pretty large. These are the 51 ohms resistors. They're easiest to solder, and I'm guessing they are not really important. I mean, you have 2 contacts here, so you can test continuity and measure if they function correctly. And they are 14 in total. And we will open this like this, and already things are spilling out. So be careful not to lose any of the components. This is one of the problems with SMD stuff. You can also buy special magnifying glasses or whatever helps you to do that. And here they all are, and you can solder them upside down, but then you can't read their value anymore, so I suggest putting them on in the right orientation. So what I just read to you is that we take our soldering iron, and it should be up to temperature now, and we will tack down the first one by first taking the soldering iron, and I'm going to zoom in as far as I can, like this, and we are going to heat the first pad with the soldering iron and for a couple of seconds, and then feed some solder in there, and you can see there is now a shiny solder blob on there. Then we can take one of the resistors, doesn't matter which way around for the resistors, and hold it very slightly down with our tweezers and put the soldering iron to the other side, and then it's already attached. However, I will show you something. If you look, there is this protrusion. You can see that it's spiky. This is not very nice, and this is where the flux comes in. Flux helps the solder to not do that, basically, because it wants to stick to the hot iron. So I'm gonna apply liberal amounts of flux here. Good flux is actually not cheap, so something like this costs around 10 euros, which is quite a lot for such a small syringe, but it will last you for a lot of projects. So the individual syringe is expensive, but over a lot of projects it's actually not that much money. And good flux is really worth a lot. And I'm gonna shift this around a bit and wait till it looks fine. This looks better. I'm not entirely happy, but that's what we are here for. You can always retouch this. You can heat it up again. Now I'm gonna turn it around and put the soldering iron to the other pad and wait till it's a bit heated. You can also see that the flux starts smoking, and feed a little bit of solder on there. So that's it. We now have our first soldered resistor. And in theory, we should be able to measure that. So let's also get our multimeter. That's how you can test if you soldered correctly. If there was no connection, you would see open line, basically. Very nice. So after a couple of resistors, you can always test how well you did. I'm gonna do this row now, and you can do the same. Okay, here we are. And this actually goes pretty quickly. Sometimes you get these little solder balls, but they will float around in the flux, and the blue coating here is actually called solder mask, and solder will not stick to that. I think they give us 14 components of each, because if you're practicing you might break some. So I have 2 of the resistors left. I put them to the side, not to confuse them with other components. And we are gonna test once more, because now we should have, I think, 12 times 51. So let's see if that is true. Let's measure down here. And we get roughly 608 kilo ohms. Yeah, which makes sense. 12 times 50 is roughly 6, it's 0.6 kilo ohms, of course. So that should be 600 ohms plus change, because we have 51 ohm resistors, and they are not very accurate. They are 5% tolerance, so that seems about right. The higher the tolerance, like there are 2%, 1%, or even 0.1% resistors, the more expensive they are, of course. Next up will be the 0805. And I'm wondering which ones these will be. 2, 4, 6, 8, 10, 12, 14. I think these are the 0805 capacitors and resistors. Yeah, it's the same deal. I will go down there. They are one step smaller, and I will tin all the pads on this side and on this side, apply some flux and add the components and take them down. And again, you can do the same. So while soldering down the capacitor, something interesting happened. And when using flux in particular, it's actually pretty easy to solder these things, because they will align themselves automatically, because they flow with the flux. But sometimes it happens that the component lifts itself up like this. This is called tombstoning because it looks like a tombstone. And it happens because the components are so small that the surface tension of the melted solder is actually pulling the thing upright. That's why you need to use the tweezers to push down quite lightly on the component. And you can also adjust it a bit. You can see that mine are a bit crummy. Using a hot air gun and a lot of flux, this will be completely straight because the surface tension will really pull the components in the right direction. But for hand soldering and for a first try, I think this is not that bad. Alright, so we have 3 rows soldered. There's a lot of flux on there, but that doesn't hurt. This is so-called no clean flux. For testing the circuit, you don't have to clean it because the flux is non-conductive. There's also conductive flux. You will have to clean the board before that. Here we have 6 mega ohms-ish because those were 500k resistors, plus or minus. And maybe as a hint, sometimes a resistor or something else will be a bit crooked and you want to remove it, or it's broken and you need to replace it with a good one. How do you get this off the board? And always apply flux. I still have plenty of flux here, but if there's no flux, please apply some. And then you can swipe up and down the component to touch all the sides rapidly, and the component will just come off very easily. So if the component is crooked or broken, that's how you get it off the PCB. And then we can put it on again or replace it with a fresh one, whatever you like. And just do what you usually would do. Actually, let's do it the proper way. If you want to really replace a broken component, let's say here's our replacement component, here it is. We have removed the broken one. Put this one here. You take a little bit of copper wick. This is copper wick, and make sure that the copper wick doesn't have any solder on it. So we snip off the dirty part, throw that away, and we take a good clean part of the wick. We add flux if there is not enough, and there can never be enough flux. Flux makes everything easier, and then we wipe down the pads first, because you want to have clean pads when repairing stuff. You see that? How nicely it got sucked up by the wick, and the pads are now nice and clean. Then we can again apply a bit of flux, tiny amount, and yeah, retin the pad on this side. Then we take the replacement component and try not to breathe in the fumes. I'm not going to turn on my fan right now, or you won't hear me anymore. So here's our replacement component. We put it down there, melt the solder, and it already flowed in place. I'm gonna hold it down with the tweezer. And on the other side, we're gonna heat up the pad, put a little bit of solder there, and we're done. You have replaced a component. That's how you can do board repairs if there's a blown, whatever that was, resistor, capacitor, diode. Okay, I'm gonna go down the 0603 and the 0402. It's basically the same, it's just getting harder to actually put something there because they are getting tiny. We have resistors and capacitors. You just do the same. I think these are the ones that we want. These 3 strips, and the rest is, I think, for the actual circuit. There's actually one more thing or trick I want to show you. I already did while you were away these 2 rows, and I used the wiping technique actually, and we'll do that for the 0402 as well, because these are so tiny that it's pretty annoying to do every pad individually, and you just need very tiny amounts of solder to actually put the components in place. So I apply lots of flux, really lots of flux. You can't have too much flux in this. And I'm taking a cleaned, so you need a brass brush or something similar, a cleaned tip for your soldering iron. And important part here as well is the shape of the tip. I'm using this, I'm not sure what you call it, but it has a flat part, and it's yeah, it's this angled thing, so you can wipe with it over the pads, and it will also keep a little bit of solder, a blob of solder at the front. If I do this here, for example, it will keep the solder here at the front, and I can wipe down over the pads and from time to time add a little bit of solder. Doesn't hurt because it will not stick and flow very nicely with the amount of flux that we're using. Careful not to breathe in the fumes. Always open a window when doing this and turn on your ventilation, which I'm not doing right now because it's very loud, but I will in a second. And just wipe down over it, and you will see that nice solder beads are forming. And those should be enough to actually tack down the component, and you won't need any additional solder. And there will be some excess solder on here, which you just wipe down on the brass brush or your standard wet brush, depending on what you're using. I like the brass brushes more because they don't give such thermal stress, but it's up to you. Okay, so these capacitors are really tiny. Resistors, of course. And the lower ones I haven't tacked down completely. And you can actually use the technique that I used for removing the capacitors to attach them. If you already tacked down one side, hold them down with one leg of the tweezers or with the closed tweezers, and then swipe left and right very carefully and press down on them very lightly. Because we pre-tint the pads, the resistor will actually sit at an angle. If you look from the side, if you look like this, it will sit in an angle because there's a little hill made from the solder, and you need to heat both sides and push gently down. Be careful not to remove it, because this is also the way to desolder that stuff. And you see I flipped one. I'm gonna reheat both pads and put him straight down again. And we do the same here and for the rest. And then we can test for continuity and for resistance. If we did everything right, we should have not an open circuit, but some kind of resistance there. And yeah, these are really tiny. And if in doubt, always use more flux. I think that's the idea here. So let's turn this on into ohms mode, and let's see if we did well or if we did something wrong. We get somewhere around 5 kilo ohms, which is fine. That should be correct. Okay, I'm doing the capacitors over here and the last resistors, the very tiny ones, and then we'll see if that works. Okay, these 042 are literally the size of a grain of sand, so you definitely need the flux to place those correctly. I'm gonna solder them now and hope that they will flow to the right position, and I think they might even solder directly because they probably conduct the heat pretty well over this short distance. There are two leftovers. Let's show you this. It's ridiculous. It's really ridiculous. They can't even get into focus quite right. Let's try it. Yeah, here you can see them. They're ridiculously small and they get lost pretty easily. So we're gonna tack them down and see if they work. And after retouching the third one in that row, I can use the test points and we read 250 kilo ohms, roughly 248 kilo ohms. That's a success. And yeah, this was definitely the toughest of them all. You can see the tiny resistors here. And yeah, I'll put down the other components around here and then we'll get to the ICs because they are the most interesting. Okay, so the resistors, the transistors and the capacitors are attached. Missing are a couple of diodes, which are these tiny things here, and the LEDs around here, plus the chips. The diodes are now a bit interesting because the diodes are of type 4148 and they are D12 through D15. That means they are D12, D13, D14, D15. And they all have their cathode up here. So you need to align the black line with the upper half of the board, which isn't really visible here in the printing, but on the schematic actually it is. So the diodes were actually a bit nasty because they are almost as big as the pads. Now they are tacked down, but I had to solder quite a bit. And they are, of course, a bit heat sensitive, so I hope I didn't break anything. Yeah, you should take care with that as well. This one even looks a bit crooked, but I think they all make good contact. Hopefully, otherwise we have to resolder some of that. Yeah, I think we can probably test that later. And now up are the LEDs which come here on the corners, and these are the ones, and I'm not sure if you can see that. I'm gonna pick one up, and on the bottom side of the LED you can see a tiny green T basically, and the little bar at the top and the line that points here down, that's actually pointing into the direction of the cathode, so of the minus, which means if we turn this around, let's try to do this very carefully on my finger, because you need to solder it the other way around. So minus is where the green is, so the cathode is actually pointing to the green side for this type of LED, which means we have to put it like this down, because the plus is on the left, the green has to go on the right. And if we were right, then this thing will light up when we apply power to it. So let's hope that is correct. Alright, tack down all the LEDs, and I think I've put them in all the right way. Now is the time for the grand finale. The two ICs, 555 timer chip and a 4070, whatever that does. Probably microcontroller, I have no idea. But you can look up the datasheet, I guess. And then we can attach, I guess, 5 volts here, or 3 AAA batteries or something like that. Yeah, so let's do that. How will we proceed with the ICs? I will tin one pin only at the corner, align the chip and melt the solder. And when the solder is melted, I can shift around the pin so that the legs will cover the pads. And then I will go from on the opposing side from pin to pin and tack them down with a little bit of solder. Make sure to have enough flux on there, but as you can see, it's covered in flux. We will clean this later as well. Yeah, so we'll do that just now. Let's start with a smaller, with the NE505 chip. So this is one chip down, and I think it looks okay. There are no solder bridges between the pins, and every pin has some solder to it, and it looks like it's attached firmly to its pads. Now to the bigger one. I already pre-tinned the lower left corner, and make sure, as I said, with the pin 1 marker, that it's aligned correctly. Okay, here we are. It's sitting not quite straight, but as you can see, it makes contact with all the pads. There is one blob of solder that I don't like down here. I will just swipe that away. And I think all the other legs look more or less fine. Yeah, it's definitely not my best job, but now that it's tacked down, it's pretty hard to get it off. Hot air gun would help here. And I'm also missing one diode here. I think I need to put that still in. I think that's one of the LEDs. But then we will give it a scrub with IPA, alcohol, which will remove all the flux, and then we attach some battery down there. So it actually turns out that with 2 batteries it will not run. It needs 5 volts, so I took 3 AA batteries and replaced one battery, the 4th battery, with a wire because I don't want to overvolt it. I also had a non-working diode down here, which was due to a broken solder joint on Q3, and for that, to figure that out, the schematic actually helped, because I figured out, okay, this is all okay, but somewhere here must be the problem. And yeah, when pressing down on Q3, I figured out, okay, then it makes contact, so I reflowed everything and it works now. Also, one of the 4 diodes is broken. I think I heated it too much. I took from one of my other kits one of these diodes, tiny things. I will need to get some replacement for if I want to solder the other kit. Yeah, because they didn't give any spares for that. They are a bit more expensive. But let's start this by attaching the wire to the spiral down here. And then you can see, I'll turn the light off. Then you can see there will be a circling light and the 4 corner LEDs will be flashing, and in the middle the LED is flashing pretty quickly. And the 4 corner LEDs are driven by the diodes in the middle. That's why the top left one wasn't working at first. So it is a success, I would say. We have the whole thing assembled and it works. Let's turn on the light again. And yeah, I think this was pretty useful. I practiced quite a bit my SMD skills, and so can you. And I think these test runs of components are pretty useful just to get the feel. And yeah, I touched up one capacitor down here because it was a bit crooked. And you can do that as well. And this thing here in the middle is of course a nice extra, that you have a working circuit that does something flashy. and you can see if you soldered everything in correctly, everything is blinking, everything is working. So all in all, I think, yeah, if you do a couple of these, then this will be a very good practice run for bigger projects, because let's face it, especially the ICs are pretty difficult, and I probably need to have a practice kit for soldering ICs like the QFP packages on the backside here. But still, this is already pretty good, and it took amazingly quite a bit of time. I think it took me 2 hours now to put together this whole thing, and the idea will be that you do quite a few of those and get faster and more confident with doing this. I think that's it for today. Thank you so much for watching. I hope this helps you in improving your own soldering skills. If you want to support me, there is a Patreon and a Ko-Fi link, and also a PayPal link. If you don't want to spend any money or can't, that's totally fine. And but make sure to subscribe and hit the like button, leave a comment. Do you have also one of these kits? Are there better kits out there, maybe even for QFP soldering? I would like to know, and I would like to try it out. But other than that, I hope to see you in the next video. Have a very nice evening.